transistor. Okay, you will be performing this kind of experiment. Not exactly this one. You just use the circuit in the lab manual that will be provided to you. So what we will be looking at here is the collector characteristic curve. Meron pa rin ibang characteristic curve sa BJT, like for example the emitter characteristic curve. For this for today, we'll have the collector characteristic curve. Let's just read this. Using the circuit shown, a set of collector characteristic curves can be generated that show how the collector currents vary with the collector with the VCE for a specified value of base current. Okay. Here you have here variable sources, variable VBB and VCC. Now in the lab, it depends on the circuit. It could be a variable resistor or it could be a variable supply like this one. So what will be done here is the IB will be varied, the base current will be varied, and you will see here that there will be a corresponding variation in IC. Now, how are you going to vary the IB? Pwedeng you increase, let's say for example, you want to increase the value of IB. How are you going to increase this? Pwedeng using a variable resistor, like you are going to decrease the value of the resistor so that the current will increase. O kaya naman, you could have a fixed resistor here and then you could have a DC, that you will be varying so that there will be a corresponding variation in IB, So it depends on the circuit which of the two are you going to vary so that you will have a varying IB. Wait lang, may titingnan lang ako. Okay. So, here, you will see here, now this is the assignment that I gave you. This is also taken from the original module that you have on your Canvas. Pinagsasama ko na lang sila. Okay? Now, dun sa assignment ninyo, you were able to compute a VCE which is 0.3 volt. So therefore, you have your VCB, dito. This is number 2 or number 3 of your assignment. Now, all of you, got a correct answer here. Your computation for VCE, kasi you used a 970 ohm resistor here. Now, your computation for the VCE is equal to 0.3, but your computation for VCB is negative 0.4. So, ibig sabihin, this will not be reverse biased. Kasi you got a negative 0.4 volts there. So, now you can change actually the RC. When you make RC to be 400 ohms, the VCE that you will be getting will not be 0.3 volts anymore. The VCE that you will be getting is 6 volts. So therefore, your VB, your VCB, will now be 6 volts minus 0.3. So 5.7 volt na yan, Hindi na siya yung negative 0.4 volt na meron kayo sa assignment. Ito kasi yung assignment ninyo Okay? Now, ano yung ibig sabihin nitong changing the value of RC? You will notice that you actually computed for IC using the formula IC equal to beta IB, right? So, when you computed for the IC equal to beta IB, your current on your number 3 assignment is 10 milliamperes. Now, when you change your RC to 400 ohms, you will notice that IC is still 10 milliamperes. No? Kasi wala naman tayong pwedeng gamitin pang ibang formula kundi yung IC is equal to beta IB. So your computation here for your assignment using the 970 ohms will still give you 10 milliamperes when you use 400 ohms for IC. So what does that mean? Ano? So changing the RC does not affect IC. Na? When you change the value of the RC, it will not affect the value of IC, but it will affect the value of your VCE. Siyempre, when the value of your VCE is now 6 volts, then your VCB na will be positive 5.7 volt, which will actually make the collector base reverse bias. Okay? So, hence, IC depends on IB and beta. Okay? IC depends on IB and beta. It does not depend on RC. Okay? So, IC increases proportionately with an increase in IB. Now, transistor breakdown. The transistor breakdown is here on the right side. Transistor breakdown occurs when the VCE exceeds breakdown voltage rating of the transistor. How will you know kung ano yung breakdown voltage ng transistor? You're going to look for the breakdown sa data sheet. Where can you see the data sheet? You can see the data sheet from the manufacturer itself, from electronic shops, from the library, or mas madali from the internet. Okay? For a particular IC, let's say for a particular transistor. Let's say you are given a 2N222 na transistor. What you're going to do is you simply type that 2N222 on Google, BJT transistor, 2N222 BJT, and then it will give you the data sheet in PDF. Tapos, doon sa data sheet, you will be able to find the characteristic, even the characteristic curve of a particular transistor. So, this characteristic curve is a generic one. It just shows you what is the characteristic of the collector. Okay? So, syempre, each transistor, na may iba't ibang part number, they have different characteristics, But then, of course, the appearance will be the same. Pare-parehan sila ng itsura. Okay? Yun lang mga values ang magkakaiba-iba. Now, syempre, this portion is the portion na ayaw nating pupuntahan, Because this portion will actually damage your transistor. And that yung damage na yon is irreversible. Once damaged, it's damaged. Pero sa laboratory, syempre, sa laboratory ng manufacturer, they do this, they increase and increase the value of the VCE, by and then doon nila titingnan, kung ano yung characteristic ng particular transistor na yon. Doon nila makikita kung saan yung breakdown, The breakdown is when there is a sudden increase in current. Okay? You will notice that this curve, is actually the same, similar to the curve of your diode, except that nakabaligtad, Yung diode mo kasi pag ganyan. Okay? Ito pag ganito, pabaligtad. True enough because this is made also of a P and an N. So, ang diode rin, made of P and N. Ito naman, 2 P's and an N, o kaya 2 N's and a P. So, that's why itong curve nila ay mayroong pagkakahalintulad. Okay? Now, wait lang. I'm looking for something. Okay. Okay. So, collector characteristic curve relates the values of IC, IB, and BCE. Na? Each collector curve is derived from a specified value of IB. Now, paano nyo iintindihin itong curve na ito? Actually, hindi mo ito, kagaya nito, ang nakadrawing dito, dalawa na agad. Tapos dito, ang dami. Hindi nyo ito makikita na ganyan. Okay? If you are doing the experiment, hindi nyo siya makikita na ganyan agad kadami, ano? O hindi, in fact, hindi mo rin makikita na ganyang dalawa agad, ano? Isa-isa lang. Okay? You will be asked to do the graph of this, ano? By changing the values of una muna, you are going to set the IB to a particular value. Tapos, for that particular IB, you are going to read the VCEs and the IC. That's the only time you will be able to come up with this. The IB here, you cannot see IB for this graph. Yung IB, alam mo lang. Okay? Hindi mo makikita ang IB sa graph. Oo, nakasulat. Kasi you already set the IB to be, let's say, 0 microampere. Okay? Or 100 microampere. Alam mo lang yon sa mind mo, alam mo ng IB is that value. Pero ang hinahanap mo talaga ay mga IC and mga VCE so that you will be able to draw this. Now, you will notice something here, Anna. You have here 4 regions of a transistor: the saturation, cutoff, active, and breakdown. This one is the saturation region. That is on the left portion of the knee voltage. The knee voltage actually is also 0.7 volt. Okay? The cutoff region naman, this one, this is actually exaggerated. Yung IB talaga na yan, yung IB equal to 0 microampere, you will be saying na if IB is equal to 0 microampere, then IC must be 0 as well. Not really. There will be a very small value of IC for an IB equal to 0 microampere. So that's why I said that this one is exaggerated. Actually, if your IB is equal to 0 microampere, your graph is somewhere here. Halos, halos kadikit na ng x-axis. Okay, so this one is a little bit exaggerated. And let us just assume that this is a very, very small IC. Okay, now this portion, you call it as a cutoff region. That is IB equal to 0 ampere line and below. Now, this one naman is the active region that is in between the knee and the breakdown voltage. This is where you want your transistor to operate when you are going to use it as an amplifier. This is where, ito naman, the saturation, the cutoff. Okay? This is for switching transistors, for transistor used as switch. For transistor used as amplifier, you want to operate it in the active region, in between the knee and the breakdown. That is when the VCE is in between the knee, that is 0.7 volt, and the breakdown. The breakdown voltage is not fixed. It depends on that particular transistor that you are using. Usually, it's a large voltage. Okay? So, nag-iiba to. So, okay, sinabi ko na ito, no? So, breakdown region, that is the right portion of the VBR, the breakdown voltage. And this region is that region that we do not want to operate because your transistor will be damaged, no? Ito yung pinapakita, is pagka-experiment ninyo, sabi ko nga sa inyo, isa-isa lang ang makukuha ninyo. Ano? And at the back of your mind, you will know that starting at the knee, let's say, meron kang certain IB. Whatever is that IB. Maybe you change the value of the VBB or you change the value of the RB in order to have that particular IB. Okay, so you already know that IB, hindi ka nagagalaw sa input. So magva-vary ka na, magsusukat ka na, ng mga VCEs and magsusukat ka na ng IC for varying VCE. Let's say, for example, the VCE is below 0.7 volt or below the knee. You will see that there will be an increase, continuous increase in collector current. Just before the knee voltage, across the VCE, you know where the VCE is, that is across the collector and the emitter. If the voltage there is from 0 up to the knee, up to just before the knee, you will see that here, you can see that the current is increasing. So, pagka ganun yung nakukuha nyo sa experiment, that the IC is increasing until your VCE reaches almost 0.7, that will be okay. Okay yon. Sa simula, you may not be able to get, lalo na if you will be using the current meter from the laboratory. Kasi this portion is so small, baka you will not be able to get good reading of current, Maybe at this point you will be able to read, Now, there will come a point that the IC will not be increasing anymore. That is after the 0.7. So, wag kayong magtataka kasi yun talaga ang dapat. That the IC will be constant. Almost constant. It's not really constant na laging ganun ang value. It will not, parang kung mag-i-increase man, it will be very, very minimal na parang sa tingin mo ay hindi na nagbabago yung collector current, After the knee, and you will see that the IC will be almost constant even if there is an increase of VCE. 1 volt, ayan. 2 volts, yan pa rin. 3 volts, yan pa rin ang IC. 4 volts, yan pa rin ang IC, Almost the same. So, wag kayong magtataka kung almost the same because that is really the characteristic of your BJT, The collector characteristic of your BJT. Of course, you will not be able to reach this because this is a large value. Since you are using your simulator, yung EDEV, it's nice to see this, It's good to see this. Hindi naman masisira ang computer mo, Hindi naman masisira yung simulator if you try to apply a VCE which is beyond the breakdown para makita nyo lang. Now, in the lab, you should not do this. Okay? And besides, our power supply in the lab is not capable of giving you the breakdown kasi malaking value ito, It could be 50 volts and we do not have a 50 volts DC in the lab. Okay. Hindi ko sinasabing fixed na 50, it depends, It depends on the actual BJT. Depende sa. Now, isa pa lang yan, You're going to set a certain IB, tapos magbabasa ka ng IC for the various VCEs. Isang curve pa lang magagawa mo. Tapos set ka na naman ng new IB. How are you going to set that new IB? Maybe you can adjust this, or maybe you can adjust this if this is a variable resistor. So you're going to increase IB. Okay, when you increase IB na, no? So maybe it's IB1. So you will be getting the same thing. So it depends kung ilang ang IB. So paisa-isa lang ang kuha, no? Isang IB, many readings. Another IB, many readings of VCE and IC. Okay? So this is your collector characteristic curve. And remember that after or just a little bit beyond the knee voltage, your collector current will start to be constant, almost constant. No? And then remember the regions, saturation region, cutoff region, breakdown region, and this is your, how do you call this, active region. Active region wherein you want your transistor operate when you are using it as an amplifier, sorry. So these are the operating conditions. Cutoff, as I have said a while ago, a BJT operating state where IC is nearly zero. Ano? Let's look at it again. This one is the cutoff. Ito, kita nyo naman eh. This one is the cutoff. The IC is almost zero. Okay? Saturation, a BJT operating region where IC reaches its maximum value. For different IBs, there is a different maximum value. Okay? For this IB, this is the maximum. This is your IC. This is the highest IC. For this IB, this is the highest IC. For this IB, this is the highest IC. Okay? So this region is your saturation. IC reaches its maximum value. Now, there will come a point also that even when you increase pa the IB, there will come a point that the IC will not increase anymore. Okay? That is already saturation. There will come a point that even if you increase the IB, the IC will not increase anymore. Parang yan na yung last. Okay? Active region, the BJT operating region were between the saturation and the cutoff, and then the breakdown region. This saturation region, you have a sloping part of the curve. Ito yon. That is when your IC is beginning to increase from zero. So this is increasing continuously. Now, both junctions are forward bias. For saturation region, both junctions, that is the base emitter and then the collector base, they are both forward bias under the saturation region. The collector has insufficient positive voltage to collect all free electrons injected into the base. This one is the active region. This one is yung nasa assignment ninyo. The base emitter junction is forward biased and the base collector junction is reverse biased. The circuit on your assignment, which is like this one, especially the number 2 curve, circuit, the base emitter there is forward biased and the base collector junction is reverse biased. But for the number 2, hindi siya ganon, you only have this base emitter forward and base collector reverse bias only when we change the resistor to 400 ohms. Okay? This is assignment na number 3. This represents the normal operation of a transistor as an amplifier. Okay, for the breakdown region, the transistor should never operate in this region because it will be destroyed. Then a transistor, of course, is not intended to operate on this region. Parang nasasabi ko na lahat ito kanina. No, let's skip this. Okay, I've said all of this a while ago. Now, this is the state of operation, no, for those three regions, operation regions. This is the active. This is what we were doing last time do sa mga circuits. Base emitter forward, base collector reverse. Pagka saturation region, that is on the left side of the knee, you will be able to operate on that region when your base emitter is forward and the base collector is forward also, just like number 3 of your assignment when the resistor is still 970 ohms. Because your VCB, you were able to get it as negative 0.4 volts. Okay? The cutoff region naman, the base emitter is reversed and then the base collector junction is reversed. No? Basta pag saturation, both forward, pagka cut off, both reverse, yung base emitter and base collector. Pagka naman linear operation, that is when you use your BJT4 amplifier, the base emitter is forward and the base collector is reverse. Not easy to remember, na? Both forward saturation, both reverse cutoff. Okay. Now here, sabi dito, sketch an ideal family of collector curves for the circuit below for IB equal to 5 microamperes to 25 microamperes in 5 microampere increment. Assume a beta of 100 and assume that the VCE does not exceed breakdown. So meaning, parang this one is a sort of a problem which is good to perform during the lab, wherein you're going to set your IB to 5, 10, 15, 20, up to 25 microamperes. So in that case, you're going to compute for the corresponding IC. You compute for IC equal to beta IB. Ito. So this is your circuit. So ito yung sinasabi na you set your IB from 5 to 25 microamperes, increment of 5 microampere. So ito yon. So when you compute for the corresponding, so wala pa ito muna actually. Ito lang yung sa given. And then the other given is the beta. And then when you compute for the IC, this will be the equivalent IC that will be 100 times 5 microamperes. That will be 0.5 milliampere. And then, again, 100 times 10 micro, then you will have 1 milliampere, and so forth and so on. Now, what your, the resulting curves are plotted, like, for example, you have your 5 microampere here, and your IC of the IC is 0.5 milliampere. Kailan nangyayari diyon? Itong, ano yung resulta ng IC equal to beta IB? Yung IC equal to beta IB na 0.5 milliampere for the first one, that occurs when the knee ito after the knee, after the 0.7 volt, ito ang ibig sabihin nito, your IC becomes constant na 0.5 milliampere at an IB of 5 microamperes after the knee. Okay, do you get it? You take a look at this one. Again, we use this formula. IC equal to beta IB. So, ang IC natin, when our IB is 10 micro, no? The IC is 10 milli. O, syempre, number one, hindi nyo ipinaplat yung IB. Isinusulat nyo lang ito. Okay? Ang ipinaplat nyo, yung IC. Okay? IC, 1 milliampere. Hanapin mo dito yung 1 milliampere. Ito yung 1. Asan yung knee? Ito. Ito yung IB na 10 micro. Pero how about this? We cannot get the information about this, itong mga nasa saturation region, dito sa table na ito. So, do you get the point here? What you are computing actually, dun sa assignment niyo, no? Yung kino-compute yung IC, na ginamitan nyo ng formula na beta IB, that is actually the IC, which is already the constant IC. Ito na yon. Okay? For that particular IB. Etong mga ito, we cannot plot it here using this information. Etong mga ito, itong IC for, let's say, for example, for a VCA of 0.1, there is a different IC. Hindi siya 0.5 milli, mas maliit. No? So that can be done by varying, no, the value of RC. Di ba dun sa example number 3 kanina, when you vary the RC, you will be able to vary also the VCE. Right? Okay. Or kung experiment naman yan, you vary the value of the VCE, like for example, you vary this, so that your VCE will be 0.1. You vary this so that your VCE will be 0.1. I'm not saying na gawin mo itong 0.1. Hindi. You vary this so that you will have a VCE here which is 0.1. Yan. Kung ano man yung VCC na makakapagpa 0.1 dyan, tapos ipa-plot mong ganon. Okay? For that particular VCE, you have this IC. Tapos vary again the VCC so that you will have a VCE of 0.2. Tapos plot again. Hanapin nyo kung ano yung IC. And how can you find the IC? Kung siya'y experiment. So, syempre, you can find the IC by inserting here an ammeter. Now, you be very careful, especially when you are doing it in the actual. You have to place your ammeter. You cut this line. Wire lang naman ito connecting wire. You cut this, or maybe here. You cut this line. Parehas lang naman itong current na dumadaloy dyan. You cut this line and then you insert the ammeter here. You can read the current by inserting the ammeter dito sa dadaluyan dapat niya. You can read the voltage when you connect the voltage across. Pagka voltage, it should be across. Kapag current, it should be dito, in series. Okay? So, for the kung face-to-face yan, ang experiment, you simply remove the wire here, you place your ammeter here, yung mga terminals ng ammeter, you connect it to the collector, and then the other portion, the other probe, you connect it to the RC. Okay, so, isa pa lang yan. So, pakatandaan ninyo, yung mga nakukuha ninyo sa lecture na IC, these are the ICs that you get. The one which is already constant. We do not know this anymore. Okay? Now, how do you draw the DC load line? This is your DC load line. Remember that you have this formula from, di ba, nag-derive tayo that we know that we know that VCE is equal to VCC minus ICRC. You know that, you used that last night, when you were doing your assignment. VCE is equal to VCC minus ICRC. Now, what you can do is, you set your IC, ito yon. The bottom, ito yung nakasulat, ito. Wait. The bottom of the load line, this one, the bottom of the load line is at ideal cutoff wherein IC equal to 0. True enough, at this portion, IC equal to 0. It is just like you are getting the x-intercept. Diba, when you are talking about straight line, you have the x-intercept and then you have the y-intercept. Okay? When you set your IC equal to 0, parang when you set the y equal to 0, then you will be able to get the x-intercept. And then, what is the x-intercept? Kung saan na-intercept. Parang ganun yan. X-intercept is that point, on the x-axis wherein y is equal to 0. And what is y? Y, of course, is your IC. What is x? Your x is equal to, your x is the x-axis is this VCE axis. Okay? The y-axis in this case is the IC axis. So if you are going to associate it with your y equal to mx plus b in your geometry, then you have there you can get the y-intercept and the x-intercept. You get the x-intercept when you set y equal to 0 and our y is equal to IC. When you set IC equal to 0, then you will have your VCE equal to whatever is the VCC is. The VCC is your supply voltage on the output side, on the collector side. Okay? So, ito yung sinasabi dito. The bottom of the load line is at ideal cutoff where IC equal to 0. So, that you will have VCE equal to VCC. Ito na lang matitira. Okay? So, this one, is your ideal cutoff. Okay? The top of the load line is at saturation, ito naman, where IC equal to IC sat. The top of the load line is at saturation, where IC is equal to IC sat. And your VCE, this one, is equal to VCE sat. Mapapansin ninyo, may maliit pa dito, You call this as the VCE saturation. You just project it there. Actually, yung IC sat pala yung meron ka, Here's your IC sat. You just project it downwards. And that will be your VCE sat. Okay? So, in between the cutoff and saturation, along the load line is the active region of the transistor's operation. So, in between this and this will be your active region. Okay? So, at cutoff, your VCE will be equal to VCC. This one. Okay? At cutoff, your VCE will be equal to VCC. Okay, the supply. At saturation, your IC sat is equal to VCC minus VCE sat over RC. The ideal here is the VCE sat is very small. The ideal is 0, but it is not actually 0, no? Because if that will be 0, andito na yon, ano? So, ibig sabihin, yung buong ito ay active region. So, hindi naman, ano? There is a small value of VCE sat. Parang active mo, simula pa lang dito, pa ganyan. Okay? Pataas, in between. Okay? So, VCE sat is, so IC sat is equal to VCC minus VCE sat over RC. This is the formula that we had last time, no? Diba? You just got it from this. Diba? You can write it as ICRC equal to VCE minus ICRC equal to VCC minus VCE. So therefore, IC is equal to VCC minus VCE over RC. But at saturation, you simply replace this by the value of the saturation current and voltage respectively. Okay? So, like here, ano? Determine, andito naman yung solution, ano? Tingnan na lang ninyo, okay? Determine whether or not the transistor in the figure below is in saturation. Assume that VCE sat is equal to 0.2 volts. So, you know how to compute for this, ano? The IC sat, you compute it as VCC minus VCE sat over RC. You simply plug in the values and you will be able to get the IC sat to be 9.8 milliamperes. So, this is your IC sat. So, your IC naman, you compute your IC using your beta IB, the same as what you did on your assignment. You computed for IC using beta IB formula, and you will have this. No? And your IB, you can compute it as well. No? Okay, so what is being asked here is determine whether or not the transistor here is in saturation. Once you have the information about the IC sat and the IC, you will be able to say, if the transistor is saturated, if the transistor is operating on the saturation region on the left side of the knee. So here you can see that the IC is greater than the IC sat. So therefore, the transistor is saturated. So if not, so sabihin mo lang, therefore, kapag hindi naman, then the transistor is not saturated. Okay? So, let's see what we have here. Okay, so we'll stop up to that part. We will continue here next meeting. Tingnan lang natin kung ano meron dito na. Okay, so we will continue on this part next meeting. I'll see you on Monday. This is already uploaded. You can do an advanced reading on this. Hold on. You will notice that some of the slides from the original slide that that is uploaded on your Canvas, some of them I just copy paste to this PowerPoint that I am using, kasi this one has many examples. That's the reason why we want to use this. But there are also some good but there are also a lot of good things on the original module that you have. So, pinagsasama na lang, ano, para tuloy-tuloy lang yung discussion, okay? But on your case, please open both, ano? I want you to practice. Nakikita niyo pa ba yung PowerPoint? Hindi na?
Hindi na po.
Hindi na, okay. I would like you, wait lang, para may pagsusulatan lang ako. Okay, I would like you to study. Kahit walang assignment, mag-aral kayo kasi ito yung kurso nyo eh. Ano? Spend time on this. Ano? Electronic devices. Lagi ko itong, alam ko, sinabi ko na rin to sa inyo dati. Devices by Floyd. To practice, there are a lot of, siyempre, ang sagutan nyo, yung may sagot, ano? Huwag nyo sasagutan muna yung walang sagot. Kasi hindi nyo alam kung tama. Okay? Better yet, if you answer those, the examples there. And those problems, odd-numbered problems, na merong sagot sa likod. Kung walang sagot sa likod, huwag niyo munang sagutan kasi hindi niyo alam, ano? So, electronic devices by Floyd, conventional current version. Okay, you download that. You can easily download that. You also have electronic devices by devices. Boylestad. I forgot the name, no? Download those two books, no? I will be getting tests here. This is a very good practice for you. Okay? Pakakatandaan nyo, ECE kayo. So, spend time on this. Ano? Even if there is no assignment, spend time on this. Okay? Nakuha nyo? Anyway, naka-record naman. Okay. Okay, for those students who have not chatted, hindi pa nakapag-chat, ano, you just chat, ano, good afternoon, or whatever greetings for attendance purpose only. I'll see you again on Monday, okay? Walang assignment. Weekend. O magsalita kayo. I'll see you again on Monday, yes?
Thank you po, Apo.
Yes, thank you po, ma'am.
Okay. Basta gising
Thank
pa
you
kayo,
po,
ha?
ma'am.
Okay, God bless. Bye. Thank you. Sige, you can leave now. God bless.